All right, 6.7 graphs of the other trig functions. Now, in order to graph the other trig functions, we have to know the sine and cosine. So, just as a reminder, we're going to graph them fairly quickly here. The highest that sine will go is 1. So I have increments of 1/4 here. And the lowest it'll go is -1. And then we just simply do it on increments of 45. We'll need 8 tick marks to cover from -2 pi to 2 pi on 45, pi over 4. So where do we start for sine? Start at 0. Good. And then we'll go what? A little less than 0.75? 1, 0.75, 0. Then we go negative. 1, 0.75, 0. And that's the pattern. Again, you should be very comfortable in drawing this graph several times. So we'll refer back to the sine for its reciprocal, which is what? It's reciprocal of sine. Not cosine. Close. Cosecant, someone said, yes. Okay, so we'll refer back to that for cosecant. And then the other one we're going to refer to, has everybody got the sine drawn? The other one we're going to refer to is cosine. Same increments. One's the highest, -1's the lowest. Pi over 4 going out to 2 pi and -2 pi. Where's cosine start? 1. Same pattern. So we go 1, then we'll go about 0.7, 0, -0.7, -1, 0.7, 0, 0.7, 1. And just continue that pattern to the left. Put a little curve on that, and we'll have the cosine. And again, we're very basic graphs. We're not getting real detailed. We could do 30, 60, we know those. So we got sine and cosine, right? Tangent. All right, let's look at the tangent now. Y equals the tangent of x. Now, the tangent function is a combination of sine and cosine. Sine over cosine, to be exact. So when we're figuring out where the tangent graph is, we're going to basically just look at where the sine and cosine is and figure that out. So we'll go ahead and continue with the increments of 1 and negative 1. And we'll go ahead and keep the 45s from 2 pi to negative 2 pi. Now we got to figure out. When I said where does sine start, obviously it's at 0, but where up and down on the y? At 0 radians or degrees, where was sine at? Where? Where's sine? At 0. So the y value would be 0. And where's cosine at? 1. So where would the tan of 0 be? 0 over 1, which is clearly 0. Right? Anything 0 divided by anything is 0. So tan's also going to start here at 0. All right, so let's do that again for 45. 45 degrees. Where is sine? About 0.7. Where's cosine? About 0.7. So what's 0.7 over 0.7 approximately? Or exactly 1. So we're at 1. Okay, what about 90 or pi over 2? Where's the sine? 1. Cosine? 0. (90) or pi over 2, we're 1 over 0, which is what? No. Anything divided by 0 is undefined. So, what occurs at 90 or pi over 2 is what we referred to before as a vertical asymptote. Vertical asymptote means there can't, no graph there. Okay, let's go negative 45. Let's go that direction so I can show you the rest of this pattern. Whereas, what's negative 45 or negative pi over 4? Where's sine? Negative 0.7, where's cosine? Positive 0.7. So what's negative 0.7 over positive 0.7? Negative 1. All right. We're about done. And negative 90. Where's sine? Negative 1. Where's cosine? 0. Negative 1 over 0 is undefined. So, we have another vertical asymptote. We connect it up. Now, if we did the in-betweens, it's not a straight line. If we did some in-between points, you would see that this looks like, basically like a miniature drain pipe. So it's going to be curved. Start at the origin, and we're going to curve it up to that other point. We're going to curve like a drain pipe. It's got a curve to it. Everybody see that? So it curves like a drain pipe. That pattern just repeats over and over and over. So at the next increment of 45, to the right, what's my next point going to be? It's either going to be at -1, 0, or 1. No, I'm going to repeat that pattern again. Not 0, -1. Okay, so here at -1, then what? Next 45 will be, and the next 45 will be, next 45 will be vertical asymptote. Little drain pipe. Next 45, -1. Next 45, 0. Next 45, which is beyond our 2 pi, but I'm going to go ahead and draw it in there anyway. 1. Next 45, vertical asymptote. Another drain pipe. If we're going to the left, what will we start with? Move it over. 1. Next 45, 0. Next 45, -1. Next 45, vertical asymptote. And again, we can finish out over here. We got 1, 0. If you want to go past -2 pi, next 45 will be at -1. Next 45 will be a vertical asymptote. How many patterns did we draw? So 5 periods, right? That's what a period is, pattern. What is the pattern length of the tangent? I mean, 2. What's 3? What's that mean? How far between is the pattern? From asymptote to asymptote, if you want to think of it that way. 1, 2, 3, 4 pi over 4s. So how far would that be? 4 45s. 45 and 45 is 90. 45 and 45 is 90. 99 is 180. So it's 180 degrees or pi. Follow me on that. 4 pi over 4s is pi, right? Okay, so the period length, okay, would actually be pi. Up here, sine and cosine, what's the length on that? Well, from peak to peak, it would be 2 pi. So the tangent is not quite as far. The actual pattern of it. Follow me on that? Any questions on how to draw the tangent graph? All right, let's go ahead and look at another graph now. Let's look at the reciprocal of sine, which is the cosecant. Again, that's the reciprocal of sine. So, in order to figure out where cosecant is, we have to draw or know the sine graph. So I'm going to change increments up just a little bit here. Still need to go to 1. I need to go a little bit further. I need to go a little bit further than that. So let's try this. 1, 2, 3, 4. I'm going to make, still going by quarters. So 1, 2, 3, 4, 1, 2, 3. So 2. You can actually go all the way to 3. We have enough room for 3. So 1, -1, -2, -3. We'll stay on increments of 45. 2 pi negative 2 pi, again, on increments of 45 or pi over 4. Where does sine start? 0. So what, at 0 degrees, cosecant of 0 degrees is going to be 1 over 0. So we start with a vertical asymptote. On the y-axis. What's the sine of 45? Let me refer back to the graph. About 0.7. Okay. It's exactly what? Square root of 2 over 2, right? So, what would that be? What would 1 over about 0.7 or 1 divided by the square root of 2 divided by 2 be? What would 1 over, or approximately 1 over 0.7? About 1.4. Okay, good. So at 45, we're going to be at 1.4 approximately. So that's going to be about right here. What's the sine of 90? We look back here. Here's sine. Okay, what's the sine of 90? 1. What's 1 over 1? 1. I don't think we need to figure that one out. All right, so we got 1. The next 45, which would be how much? 3 pi over 4, or, figuring it out yet? What's the next one? 135? 0.7 again. So what do we go back to? We go back to 1.4 approximately. Okay, so we got pi over 2, 3 pi over 4. So it's going to be what? Pi. So what's happening at pi? Back to 0, which causes a vertical asymptote. Now, this kind of looks like a, what do you guys going to call it? Parabola. It's not a triangle. I can't really say U because it continues to go out. So parabola continues to go out as well. It's going to keep approaching and approaching and approaching, getting closer and closer and closer. I'm going to make these a little bit bigger. To that asymptote. We'll never touch it, but it'll keep getting closer and closer and closer. So I'd say it acts very much like a parabola. Now, that pattern is pretty much the same. We got to repeat it in the negative now. Because if you look at our next point, which would be 5 pi over 4, where are we at? And here's 5 pi over 4. What's now my value? Negative 0.7. So we have 1 over negative 0.7, which is going to be negative 1.4. The next is going to be 1 over negative 1, 3 pi over 2, or 270. See the negative 1 down here? So 1 over negative 1. And then the next one's going to be back to the negative 0.7. And then the next one's going to be back where? Where's 2 pi at? 0, which is going to cause an undefined vertical asymptote. So we have, again, looks like a parabola. It keeps getting closer and closer and closer. It's not a V. Okay, it curves. It keeps getting closer and closer and closer to that asymptote. And that's it. That's the full pattern or period length, okay, of the cosecant. So what would that length be? What's the period length? 2 pi. Okay, the pattern length is 2 pi. So let's repeat it over here. Right. Well, you're going to see here, let's draw the left side. Pattern's going to continue. So I was up high, I'm down low, so I got to go down here low again. So after the vertical asymptote, we're going to start at negative 1.4. And then we're going to go to negative 1. And then negative 1.4. And then vertical asymptote. Then I'm going to go back up high. And I'm going to start at 1.4. Then 1. Then 1.4. And then another vertical asymptote. Now this is on increments of 45. Again, we can find more points in between. We use 30, 60, other nice angles. That's the pattern. So you see the pattern now. It's a high and a low together. That makes up a pattern. High, low. It doesn't go high, 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 high. They're not all above the x-axis. They're not all low, 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 low. Pattern's high, low, high, low, high, low, and so forth. That would continue forever. Any questions on that? All right, let's now draw the secant graph. Which is the reciprocal of cosine. So we're going to build this pretty much the same way we built the cosecant. I'm going to change increments just a little bit, I think. Here. See if we can do this. Is that going to be enough? 1. Yeah, that's going to be enough. So we got 1. This is 5.25. So this would be 1.5, right? Let's just stay with what we did. That's not going to be enough. I like that better. So the same way we approach the cosecant. We're going to go ahead and just same thing. I thought I might be able to sneak it in there, but it's just a little bit, not quite large enough. Increments of 45 still. From 2 pi, negative 2 pi to 2 pi. So pi over 4 is our increment. Again, you want to pick out important ones, pi over 2. You can label them all. If you want to skip, go to pi, 3 pi over 2. Those are our big ones. 90, 180, 270.
For every one goes 362 pi, and the next one goes 3 pi. The next.
Yeah, because we got 1 pi, 2 pi, 3 pi. Yeah. Yep. Again, these are on 45 pi over 4, so it'd just be 1/4, 2/4. We got 3/4. We can label them all. 5/4 would be in between here. 7/4 would be in between there. All right, so we have to refer to the cosine. Where does cosine start? Okay, so at x equals 0, or 0 degrees, the secant of 0 would be 1 over 1, because the cosine of 0 is 1. So we start where? Also at 1. What would be the cosine of 45, or pi over 4? 0.7. So it'd be 1 over 0.7, which we figured out with cosecant is about 1.4, right? Okay. Notice before we go back to the graph, that occurs at pi over 4 and negative pi over 4. So I'm going to go ahead and put both of those in. 1 over 0.7 for both of those. So we're going to have 1.4 and 1.4. And at positive and negative 90, I think you're going to see something similar again with cosine. What's happening at positive and negative pi over 2? Both are 0. Well, for our reciprocal then, that would give us 1 over 0 for what situation? The undefined vertical asymptote, both sides. So that's our little pattern. Little parabola like stuck between the asymptotes. Do we need to refer back to cosine to finish this? It's going to be pretty much the exact same pattern we just did with the cosecant. So we have one high. What's going to be next? Have one low. Where's it going to start? Close. What's the first point we run into from the asymptote? What we're looking at would be 1.4. We're looking at increments of 45. So negative 1.4. Okay, good. I'm going to erase these right here so you can see a little better. Okay, so at negative 1.4, and then the next increment of 45 would be negative 1, and then the next increment of 45 would be negative 1.4, and then we'd have an asymptote. So what would be next? Now we go high again, starting at positive 1.4. Since we're on increments of 45. Pi over 2 would be 1. And then the next 45 will be 1.4. The next 45 after that, we'd have an asymptote. Everybody following the pattern here? So we're going to continue that pattern on the left. So I have one high, I need one low. So at negative 1.4, negative 1, 1.4, asymptote. And then we go back to the top. 1.4, 1, 1.4, asymptote. Secant. What do you think? Note that the secant and cosecant are almost identical. How are they different? Okay, that's a great way of thinking. Where they start. We could shift the cosecant over pi over 2 or 90 degrees to make the secant. We could shift the secant pi over 2 or 90 degrees over to make the cosecant. Okay, they're 90 degrees away from each other, just as sine and cosine are. Any questions on graphing those?